Hello everyone, welcome back. In the last class we saw block ciphers. Now it is time to start with the next cipher, that is called stream cipher. What happens in block cipher? Our message was divided in a block and then each block is encrypted. Okay, so the idea of stream cipher is to use a key stream. Use a key stream. Say z equal to z1, z2, and so on, to encrypt the given whole plain text. That means I'm not going to divide it. I am going to have a key stream. I am going to derive a key stream and then I am going to encrypt each of the plain text. So suppose my plain text x is say x1, x2, and so on. Then encryption will be your ciphertext y is equal to y1, y2, so on. Y1 is what? It is just encryption with z1 to the plain text x1, then with respect to z2, x2, and so on. That means this x1 is encrypted by this, x2 is encrypted by this, and you'll be getting your ciphertext y1, y2. So here I'm not going to divide it in a block. Here what I'm having, I will be having this key stream. I'll be generating this key stream and then I'm going to do the encryption. So we can generate the key stream using key stream generator or algorithm. On the basis of key stream generation process, the stream ciphers can be divided into two parts. So here the key stream is the main important part. On the basis of key stream generation or algorithm, stream cipher is divided into two parts. Stream cipher is divided into two parts. The first one is synchronous stream cipher and another one is non-synchronous. So first we will be seeing synchronous. Synchronous stream cipher. So in this stream cipher, the key stream is generated from the key. Yeah, the key stream is generated by the key only. That means I'm not going to use something else. That means I'm not going to use my plain text here. That's why it will be just by using my key. I'll just write independent to the plain text. Independent to the plain text. That means before starting with our encryption decryption, I can generate my key stream just by using a key. Correct? I'll be having a key. I can generate a key stream, and then while encryption, I can use it. Whereas in the case of non-synchronous, the key stream depends on your plain text also. That means you cannot generate the key stream before the start of the process. You need the plain text also. That's why it is called non-synchronous, because synchronous means it is flowing properly. That is, you are not going to depend on something else. That's why it is called synchronous. Whereas in the case of non-synchronous, it is dependent on the plain text, because as I told you, key stream depends on that. So a simple example is even your Wigner cipher is a synchronous stream cipher. Wigner cipher, let me just tell you. Yeah, Wigner cipher has synchronous stream cipher. Yeah, what happened in Wigner cipher? Sorry, let us see. In the Wigner stream cipher, we used to divide it in the block, correct? Yeah, look at this. So suppose my key was cry, so CRY here, then CRY here, then CRY, and last CRY. This is what my key. Now, do you see, if I write everything together, then this is my key stream actually, and it depends on your key. Key was cry, and I am generating my key stream. What is my key stream? Cry, cry, cry. It has been written how many blocks I required. So that is my key stream. So it is again stream cipher. So I can write it as, yeah, your key was Z26 raised to M, plain text, cipher text, and actually here one more thing I need, that is key stream alphabet. So let me denote it as, say, L. L is denoted as key stream alphabets. L is also Z26. Okay, now how do you define your key stream? Zi is equal to, it is key I, 1 is less than I is less than M. This was your key. Earlier I am having K1, K2 up to M length key I was having. So my key stream, this is how I am generating key stream. So first M variable will be same your KIs, that is Z1 is K1, Z2 is K2, Zm is Km. Then after that, when I am having M plus 1, then this is what I am going to repeat it, that is Zi minus M, when I is running from greater than M, greater than equal to, if I have written, then M plus 1, correct? So it is something like Z1 is K1, Z2 is K2, Zm is Km, and Zm plus 1 is again K1, Zm plus 2 is again K2, correct? So this is how this, that's why this Wigner cipher is a synchronous stream cipher. This is an example of synchronous stream cipher. Even if you observe, shift and affine cipher are special cases of stream cipher where the key stream is constant. In that case, your key stream is having only one variable, if you see in the case of shift cipher, and even in the case of affine cipher. In general, in general, a block cipher is a special case of string cipher. A block cipher is a special case of stream cipher. Where key stream is, where key stream is the representation of keyword of the block. The representation of the keyword of the block cipher. As I told you with that Wigner cipher example, there are some more definition, that is periodic stream cipher. A stream cipher is called periodic if say z I plus d, that means suppose d is the period. If I am saying, then it is something like this: z I plus d is equal to z I for all I is greater than equal to 1. So d is the period I am having. So in the previous case, in the case of Wigner cipher, m was the period. That means after m, my key is going to be repeated. Okay. One more stream cipher is linear feedback shift registrar. Linear feedback shift register. It is again a way to generate key stream. We call it as LFSR. Yeah, in that case, what happens? The suppose I am having my key string, that is initial key string I'll be giving. Initial key string, say I am having k1 k2 up to km. Okay, and we can generate a key stream of higher period. Correct. Earlier I was having the period m. We can generate a key stream z1 z2 of higher period, which is greater than m actually. So how we are going to do it? Let us see. Z I plus m is equal to summation j is equal to 0 to n minus 1 cj into zi plus j. Zi plus j modulo 2 for all I greater than. That's why it is called linear, because it is linear combination of, see, earlier I was having z1 z2 up to zm, because z1 was k1, z2 was k2, and zm was km. Then zm plus 1 will be linear combination of all these people. Zm plus 1 is linear combination of all these people. Zm plus 2 will be linear combination of all these people. Correct. So that's why it is called linear feedback shift registrar. So thus in the stream cipher, the secret key consists of 2m values actually. What are the secret keys? These CIs are also my secret key, and this KI. So my secret key is having K1, K2, Km, and this C1, C2 up to Cm. Or the notation, yeah, I have written Cm, yeah. So one important instruction is here that since an m-bit state vector can only assume 2 raised to m minus 1 non-zero states. So the maximum sequence length before repetition is the maximum sequence length before repetition is 2 raised to m minus 1. That means now I can have with some technique I can get a string whose period is 2 raised to m minus 1, which is very high, correct? Maybe I can put it as a theorem. The maximum sequence length, maximum period by an LFSR of degree m is 2 raised to m minus 1. But not in all the cases. It will be only if your key stream is of particular value. Actually, it should be having some condition. So what is the condition? The question is, under what condition can we find a maximum period? Maximum period key stream in LFSR. Okay, so what happens? We can associate a polynomial to the given LFSR feedback. For example, I was having this c m minus 1 up to c1 c0, the coefficient. I can associate a polynomial, say polynomial p of x is x raised to m plus c m minus 1 x raised to m minus 1 plus like this. I am associating a polynomial with the constants, correct? So if the polynomial p of x is primitive polynomial, if p of x is primitive polynomial, then we get a maximum period. Then we get a maximum period. Maximum period of LFSR. What is the maximum period? Actually 2 raised to m minus 1. So we have to choose our coefficient such that this polynomial is primitive polynomial. Okay. Yeah, thank you so much. So in the next class we will be seeing what is non-synchronous stream cipher.